Okay, students, 7.5, we're going to solve special types of linear systems. So these are a special type, and you're going to see in a minute. A linear system can have no solution or infinitely many solutions, and you're all real numbers, sometimes they call it. So you are familiar with that. We've been touching on that a lot. A linear system has no solution when the graph of the equations are parallel, because they never intersect. All the lines that we've been solving intersect at one point. But if you have two lines that are parallel, they're never going to intersect. So since they don't intersect, they can't have a x and y. So we call that an inconsistent system or no solution. So you can see it right here. So when we say inconsistent, it means it has no solution. A linear system that has infinitely many solutions when the graphs of the equations are the same line. So if you have the same line and you solve it, and you have like y equals 5x plus 2, and then you solve the other one, you get y equals 5x plus 2, it's the same line. So that means that there are infinitely many solutions. All the numbers that work on the first line work on the second because they're the same. So that's what it means when you get no solution and you have gotten no solution. So now you see it graphically. They're parallel lines, and infinitely many solutions are the same line. So let's go ahead and do this by algebra, and then do it by graphing. So there's two ways that you can do it. So let's go ahead and do it by elimination. It's set up real nice. The x's and the y's are the same, but I'm going to have to make one a minus. So you're going to see what happens. Negative 3x minus 2y equals negative 2, and then rewrite the first one. Okay. So you notice the x's and the y's cancel out. So you put a 0 here. It means you have none. So you have to write that. 10 minus 2 is 8. You have to have some kind of statement to see if it's infinitely many solutions or no solution. Does 0 equal 8? No, it doesn't. So that means you have no solution. Alright, so I'm going to show you the other way where we're going to graph it, and you can see what the lines actually look like. So now I'm going to graph it. Same thing. Same lines. Okay, so just change it into slope-intercept form. So I'm going to take the first one. I'm going to say 2y. By now you know plus 3x is going to be minus 3x. Plus 10 is already there. Divide by 2. So y equals negative 3 over 2x plus 5, right? And we're going to take this one, we're going to subtract 3x, same thing. We've got 2y equals negative 3x plus 2, because that's there already. We want to write it in slope-intercept form. Divide by 2, and let's go ahead and rewrite this. Negative 3 over 2x plus 2 divided by 2 is 1. So here are your two lines, all right? So what do you notice that is the same? Hopefully you're looking and you can see that they have the same slope, but they have a different y-intercept. So the graphs, I'm just going to throw it up for time's sake, look like this. So one of the ways that you can tell without even solving and just looking at it when it's in slope-intercept form is if they have the same graph. Then you know, same slope, then you know for sure that it is going to be parallel lines and inconsistent. They never cross, so they never have a x and y. All right? Okay, so we're going to graph. I'm going to show you both ways of lines that are infinitely many solutions. So let's go ahead and solve it first algebraically. Okay, so this is set up with substitution is best, because y equals 1/2 x plus 2. So I'm going to substitute it in here. So x minus 2. So where this y is now up top, I'm going to put 1/2 x, and they made it real nice because half of 2 is just 1, so that's kind of nice. Alright, so x minus 2 times 1/2 x is just going to be a minus x. Then negative 2 times positive 2 is negative 4 equals, sorry I forgot to write, I just plugged it in and forgot to write the equals 4 here, negative 4 here. So x minus x, they cancel out, and I'm left with negative 4 equals negative 4. So you know that that is true. So that means it's the same line. Okay? So now I'm going to show it to you graphically. This is already solved for a slope-intercept form. That means if I solve the top one, I'm going to get y equals 1/2 x plus 2. But let's go ahead and do it. So I've got it right here. So x minus 2y equals negative 4. Subtract x, subtract x. Negative 2y equals negative x minus 4. Divide by negative 2, negative 2. And y equals negative divided by negative is going to give me a positive 1/2 x. Negative 4 divided by negative 2 is plus 2. So here it is. So look at them. They're exactly the same. Alright, so if I graphed it, I only have one line. Do you see it? Right here, they're the same line. Alright, so you can tell by solving it algebraically what it will look like. It will be a true statement, or you can look at it and you can see that they're both the same line. So you have to understand both, looking at it as a graph, what it means, and being able to solve it algebraically. Okay, so what you need to do is write this down, because this is a little table that will make it very simple for you. Okay, identifying the number of solutions. When the equations of a linear system are written in slope-intercept form, so we always want to write it in slope-intercept form, you can identify the number of solutions of the system by looking at the slopes and the y-intercept of the line. So here you want to put this down, number of solutions, slope and y-intercept. If it has one solution, that means they intersect, they have different slopes. Okay? If they have no solution, when you solve it into slope-intercept form. So let me write example here for this one. One solution, so say I had y equals 2x plus 5 and y equals negative 1/3 x minus 2. That's an example of one solution. The slopes are completely different. No solution means they have the same slope but a different y-intercept. So an example of that would be y equals 2x plus 3 and y equals 2x minus 5. Okay, you can see it's the same slope but a different y-intercept. Then infinitely many solutions means you have the same exact thing. Y equals 1/3 x plus 5. Solve the second one, you'd get the same thing. So those are little examples to help you remember. So even before you graph, once you have it in slope-intercept form, you just look at it and know, okay, I'm going to have one solution, no solutions, or infinitely many. Okay? So this last part of homework is fairly simple. They just want you to identify how many solutions. So I'm just going to do a couple. Tell whether the equation has one solution, no solution, or many solutions. So here's the first one. Here's this line and this line. Remember, we have to get it in slope-intercept form. Alright, so I'm going to solve the first one. Y equals 5x is going to be negative 5x minus 2. Then this one, I'm going to add 10x and add 10x. So I get negative 2y. Remember, this cancels. So now I'm not showing every step because we've been doing this for a while, so you should understand what I'm doing now. Okay, so y is equal to 10 divided by negative 2 is negative 5x. 4 divided by negative 2 is minus 2. So which ones do we have? They're exactly the same, so we have infinitely many solutions. So that's how easy it is to tell. And that's what you would write on your test or quiz. And we're going to do one more. Let's go ahead and do this one and see what type this is. 6x plus 2y equals 3. 6x plus 2y equals negative 5. Okay? So I'm going to say 2y equals, that will become negative 6x plus 3, divide by 2, and y equals negative 6 divided by 2 is negative 3x plus 3 over 2. Same thing here. This is going to be 2y. 6x is going to be negative 6x minus 5 divided by 2. And put it underneath to look at it. That is negative 3x minus 5 over 2. So here you can tell by the slopes are the same, but the y-intercepts are different. So when the slopes are the same, this is parallel lines, so no solution. They never intersect. They always say stay the same distance apart. Alright? The slope, if you start at a different point, which is one starts at 3 over 2, 1.5, one starts at negative 5 over 2. So if you start at a different point and you keep the same slope, then that's how lines stay parallel all the time. That's how they do tracks and roads. They start at a different point and they keep the same slope. And that keeps them the same distance apart as long as they need to do that. Alright, so that was pretty straightforward. I'm just going to throw up, as usual, a word problem. That's one that works out to no solution. But let's look at it. I'm going to just go ahead and use this. So an artist wants to sell prints of her paintings. She ordered a set of prints for each of 2 of her paintings. Each set contains regular prints and glossy prints. So these are the regular prints, this is the glossy, and here you can see that this will be the total cost. Find the cost of one glossy print. So I know that the regular, so I would most probably say 45R, they're most probably using X and Y, I can see that they are. So they write a system and say let X be the cost in dollars of a regular print and Y be the cost in dollars of a glossy print. Okay, so this is not in slope intercept, it's standard form. So like I said, if I was doing it, I'd say 45 times R plus 30 times G to distinguish the regular from the glossy rather than X and Y equals 465. So you can see the first equation comes from here. Then the next equation is 15 times X plus 10 times Y equals 155. So now we're going to go ahead and we're going to eliminate. So I'm going to take it from there and pick my way to do it. I'm actually going to rewrite it as R and G because I prefer it like that. So 45, I'm going to go ahead and lift this up so we can see more. 45R plus 30G goes with the glossy equals 465. Then we have 15R regulars plus 10 glossy prints equals a total of 155. So if you have 2 system equation and you have a certain amount, 15 regulars plus 30 glossies equals 465, then you have another pair where 15 regulars and 10 glossies equal 155. You can use that to find out how much regular and glossy is, as long as we don't have a no solution. So I'm going to go ahead and multiply. I like 10, so I'm going to multiply this one by -3. I don't know what they did, but I like to do that. So this will become -45R. -3 times 10 is -30G. and then negative 3 times 155 is negative 465. Uh-oh, I already see that we're going to have a no solution because everything's exactly the same. So 0 equals 0. There are infinitely many solutions, so you cannot determine the cost of one glossy print. Normally you can, but in this case, if it comes out to, sorry, it's a true statement, not no solution, it's true. Sorry, I said the wrong thing. So infinitely many solutions, and because it is true, you can't determine. But a lot of times, with these word problems and stuff, you can find out how much a regular print is and a glossy print. But they've just set up this special type to do with infinitely and no solution. The last thing I want to show you is this. So this is what it looks like. This is now a visual to remember. You wrote down that little on the piece of paper when you solve it for slope intercept what it looks like algebraically. Here it is visually. If you have one solution, normally you're going to have a positive and a negative. Two lines are going to intersect. Alright, they have different slopes. Here, if they're parallel, the lines have the same slope and a different y-intercept. So I would definitely have this down because it's a visual and also it's written here. So this is even better than the note before. You can see it by a diagram and by the writing. So the last one, infinitely many solutions. The lines are the same, so they're exactly same slope and same y-intercept. And that wraps it all up. Okay guys, God bless, and I will see you for 7.6.